So in this video, we're going to cover a couple of the different modules that are available. So in the last video, I covered a simple delay network that was using two delays, much like this. But it's just so you can see this could apply to a delay network. We're coming on in one, and that's going into the delay, and then out of the delay into this mix module. So if we have a look over here, you can see in one is ADC in one, which is that, and then in two is the delay left out. Okay, and then likewise for in two, this is going into delay right, and then into the mix module, you're going to see ADC in two and delay R for right. So you can alt click on a module to see the connections, where what's coming into it and what's going out, and those modules that are attached. Basically, what we're going to do with the dry wet control, so I'm going to cover a subtract module, I'm going to cover the table modules, multiply modules, and switches, etc. So there's a lot more modules than you would actually need for what I'm going to be demonstrating. I'm going to show what happens if you use like a table versus using switches and describe the difference. What we've got is two mix modules, and I want to basically control the level between them. So if we're going to have a dry wet control, we want it so that when it's 0, that everything's on dry. So 0%, that means we've added in none of the delay signal. You basically want that to be dry. And when it's 100% wet, just have the delay. I've gotten a percent knob, and I've set up a few different monitors. Okay, so this is you can ignore this one down here for the moment. So this is a dry wet control. Okay, so at 0, we want it to be dry, and at 100%, we want it to be 100% wet. And then in the middle, obviously, it should be a mix of the two. So there's a couple of ways of achieving this using one knob to basically control two different parameters. So I've set up 3 different monitors. The one is monitoring what the knob is set up to. So this is actually taking the input from the percent knob. And then I've got another one which is monitoring the dry, and this one's monitoring the wet values. So if I go back to emote, you can see if I drag this down, this is the value that's coming out of this knob. Okay, as you can see, it's 0, it's 0. At 1, it's 1. So we can say, okay, well, when it's 0, the actual delay is turned down to 0, but then the dry signal should be on 1. So we actually have to do the inverse with this knob. So it has to turn the one up while the other one is down, and vice versa, etc. Basically, I've connected this percent knob, which is going from 0 to 1, actually, even though you're seeing the percent symbol, and that's what this percent knob does. It basically divides the values. So if you're going to have 100% minus 100 to plus 100, then that's essentially going to be minus 1 to 1, because it's dividing that value by 100. This mix module, you can see the amp values, and the minimum is minus 1, the maximum is 1. But we're only going to work within the 0 to 1 range. This knob is perfect for giving you a 100% range to work with when you're working within a 0 to 1 range. For an actual module, but to the end user, they're seeing a 0 to 100%, which is better than working in decimals. So what we're going to do is use this knob's value, 0 to 1, to control one of these values. Okay, so what I've chosen to do is send it into amp 2. So this knob directly, without actually going through any other modules, is going to be able to control and turn up and down the wet signal. And then as you turn this percent knob up to 1, it's then going to turn the amp 2 up for this dry wet control. But then what we need to do is we need to invert it. So what I added was simply a subtract node, connect the percent knob into that. So we've got to say 1 minus whatever this value is set to, that difference is then going to be output to amp 1 for the dry signal. So when I turn this up now, this dry, you're seeing that this is the 1 minus 0 is equal to 1. So as I turn this up, so then we've got 1 minus 0.48 is equal to 0.52. Okay, so that hopefully that makes sense. That's basically a simple dry wet control. I can then use this table as well. The reason I'm actually showing this, because this is an alternative workflow. That one's going there. So we want to disconnect that, and I want to send that there. Quite simply, the subtract is just basically a 1 minus whatever. There's only two inputs to that. Whereas a table, it only has a single input to that, but within this table module, you can then add several entries. So when this module receives 0 from the percent knob, then basically it's going to output 1. So now it's doing the inverse. So because this percent knob is outputting a 0 to the delay signal, but then when it goes through this table, it's basically going to output a 1 in the 0 state. Then as you go from 0 to 1, when that hits 1, then you're going to be outputting 0 from here. Now, one cool thing about the table, and a switch for that matter, if the select signal has a fractional value, the output will interpolate between the two table entries. So that's quite important because many things become possible, and I demonstrate a function later where you can basically add more entries into the table to have a little bit more granular control over some of the capabilities. In this case, we can basically get rid of the subtract knob, and now we're just going to output a 0 to 1 to this, and it's going to interpolate between 1 to 0. So now we're doing the inverse. So if I push that, as I turn that down, you can see likewise we got the 1. It's kind of like doing the 1 minus, and then as I turn that up, but it's actually just interpolating. It's not doing any math from what it's receiving other than just going from the 0 value in the table up to the 1 value. In this example, we're going to use the same dry wet percent knob. Instead, we're going to use table with multiple entries. Instead of even taking direct values from this percent knob, I'm going to bypass that. I'm just going to go straight into a multiply, which I'll explain in a second, and then into ctable for the dry signal and 1 for the wet signal. So as you'll see here, there's 5 entries in this table. And I can basically specify that, well, at 0 on this knob, I want it to be 1. But then at maximum, which is going to be 1, I want that to be 0. But then I can set other values in the middle here, and as the knob gets turned up, it'll then interpolate between these values, and that's the cool thing about the tables and the switches. You can create your own custom tapers. Now, I've set it so that at the midpoint I've got 0.5 value, but then in 4 I've got 0.1 instead of being 0.25. So basically it's going to accelerate its turning down to 0 between input 3 and 4. And then for the wet table, this one's going to be the inverse. Okay. Now, why do I have the multiply node? Because as I said, this percent knob only goes from 0 to 1. So if I multiply that, and let's just output that to the knob now. So it's going to multiply this by 4. Because there's 5 entries in the table, and the first entry is actually 0, so even though this goes from 1 to 5, it's going to be 0 to 4. So I multiply this percent knob by 4, and then I go into the table. So percent knob, when you multiply 0 by 4, then that's still going to output a 0. So it's only really as we get to 1, what number do we want that to be? So 1 multiplied by 4 would be 4. So this is going to be entry 0, 1, 2, 3, 4. I think that they should just have these inputs named, as per the counting order in the software, because it does actually make it a little bit confusing. So I multiply it by 4, then that's going to control the tables. And now the table, you can see the dry table is going to the dry monitor, and the wet table is going to go into the wet monitor. And then we'll be able to see in the H9000 what that looks like. So at 50%, you can see that the knob value is equal to 2. Maximum, it's going to be equal to 4. At 0, it's going to be equal to 0, because 0 times 4 is equal to 0. A 0.5 multiplied by 4 is equal to 2. So that's how that all works out. And then, we're going to be traversing the table from entry 1 right up to 5. You can see at the midpoint, they're both set to 0.5. So that's the same as if we were doing it the very first technique. But what this allows you to do then is have your custom tapers, so that around this point, we're at a 0.076 wet value, and the dry value is at 0.81. What you can do with this is create your own custom tapers that are very predictable, because for every entry at the table, you're going to see exactly what's going to appear there, and the interpolation gives you all those different values.